Hi, my name is Ronnie Haddad and I'm a solution architect at Red Hat. Today we will be discussing Project Kepler, Red Hat's approach to help our customers measure energy consumption in Red Hat powered infrastructure. So first, a little bit of background about power measurement. Understanding CPU power consumption is crucial for energy efficiency. Several factors influence it, including dynamic power consumption, which originates from the activity of logic gates within the CPU. When these gates toggle, energy flows as capacitors are charged and discharged. This dynamic power is approximately proportional to the CPU frequency and the square of the CPU voltage. We also consider short circuit power consumption and power loss due to transistor leakage currents, where leakage current is also a function of thermal temperature. By focusing on frequency-based tuning, we can optimize dynamic power consumption. Now, here's a high-level overview of the Kepler ecosystem and the integration points. Kepler collects power data from various environments, including edge devices, public clouds, and private clouds, supporting both physical hardware and virtualized infrastructure. This raw data is then fed into an observability console for monitoring and analysis. Kepler also facilitates ESG, which is environmental, social, and governance reporting, allowing organizations to track and report on their environmental impact using the Kepler data and other data as well. So when it comes to energy measurement, there's often a gap between the ideal approach and reality. While direct measurement of power consumption can be challenging and sometimes impractical, Kepler employs an indirect measurement methodology. This approach allows us to accurately estimate and approach the truth in an imperfect world, providing reliable energy consumption data without requiring intrusive hardware modifications or complex setups. And finally, Project Kepler is a Kubernetes-based efficient power level exporter designed to address the challenges of energy consumption in cloud-native environments. One of the key features is a reduced computational resource footprint achieved through the use of eBPF probes. This makes the probe lightweight and efficient. Kepler also supports machine learning models to accurately estimate energy consumption, leveraging a science-based approach to provide reliable data. For reporting, it offers per pod energy consumption reporting encompassing CPU, GPU, and RAM usage. It supports both bare metal and virtual environments and integrates seamlessly with Prometheus for data collection and visualization. You can find more information and the project source code on GitHub at sustainable-computing-io/Kepler. Okay, so let's go over to our cluster here to see how we can configure Kepler. So what we do is we go to the OpenShift-monitoring project and we create a config map. So I've already created a config map. Here's what the config map looks like. So I will include these instructions in the description, but it's pretty simple. We create a config map in the OpenShift-monitoring namespace, and we add enableUserWorkload with the value true in the config.yaml for this config map. So that's pretty much all it is, after installing, of course, the power monitoring operator. So let's check that on our cluster. Config map. So in fact, I am in the OpenShift-monitoring project. So if I check the config map cluster-monitoring-config, here it is. So enable user workload to true. Now, if I go back into my cluster, so here in the operators, when I go to OperatorHub and I look for power monitoring, so that's the operator and it shows install. So if it wasn't installed, we click on it and then we click install and it installs, and then we create the config map and we should be good to go. So here I go to my dashboards. So in the observability section, I go to dashboards, and then I look up power monitoring, and then I could check the power monitoring by namespace. So now let's look at one of the namespaces. So we go to power monitoring per namespace. And so here I could choose a namespace. I'm going to choose one of the namespaces I've been working with. It's called iLab. So this is the total power consumption. These are 3 pods in the namespace. You see here there's a pod that has an energy spike and goes back to pretty much 0. And so if we go back and look at that pod, so let me go to my iLab project and see my pods. All right, so here it is. The backend project is crashing, and so that's the reason for the spike. So here it is, energy consumption and monitoring simplified using Project Kepler on OpenShift. Thank you.